Hello, and this is part one, practice problems of integration. These practice problems will require a review of power rule, some trig integration rule, constant rule, or constant integration rule, but no use substitution yet. So these are pretty simple ones. So let's begin. So 1a, we have to take the integral of 5 dx. So 5 is a constant. So your answer is just going to be 5x plus c, right? Because we have no plus c's because we have no boundaries. So you could also have took out that 5, put a 1 here, and then the integration of 1 is x, and then you still have to times this by 5 plus c. As you can see, you still get 5x plus c. Okay. The next one, we got to take the integration of -3 times e to the x dx. Do not use integration by parts. What I would do is factor out, take out a constant if you can, and -3 is our only constant, so you take that out. Okay, and then what is the integration of e to the x? It is just e to the x. And then bring down the -3, and then don't forget the plus c. Okay. I think they're all unbounded. All of these examples are unbounded. Okay, so 1c, we have to take the integration of 5 over 6x dx. 5, 6 is a constant, so you take it out. And then you're left with 1 over x dx. And what is the integration of 1 over x? It's do not write it out as x to the -1 and use the power rule. Instead, if it's just 1 over x or 1 over x to the power of 1, it's just going to be ln of x, or ln of absolute value of x. And then we had this constant 5, 6. And then don't forget the plus c. Okay, so that's your final answer. Okay, 2a, the integration of 2 times sin of x dx. Do not apply integration by parts. Instead, factor out that 2, that constant, and then use your trig integration. So what is the integration of sine x? It is negative cosine x. And then you still got to multiply this by 2 plus c. So your final answer is -2 cosine of x plus c. Okay, let's move on. B, the integration of pi times cosine x dx. Pi is technically a constant. It's about like 3.14, so take out that constant. And what is the integration of cosine x? It is positive sine x. And then you still have to times this by pi. And then don't forget you have the plus c. So your final answer is pi sine of x plus c. Okay. The integration of 1/2 secant square x dx. 1/2 is a constant, so that's the first thing I would do, factor out that constant. Now, what is the integration of secant square x dx? It's a special, it's not use substitution, it's just part of your rules. The integration of secant square x is positive tan x. And then we still have to multiply this 1/2, multiply by 1/2 because we factored out that 1/2. And then plus c. Okay. D, the integration of negative secant x tan of x. Um, so this minus or this invisible -1, I'm going to take it out, factor it out. What is the integration of secant x times tan of x? It's just no, do not use u substitution. It's just it's just one of your integration rule. The integration of secant x tan of x is positive secant x, and then you still have this -1, and then plus c. Okay, so e, we got to take the integration of 2 over 3 square root of 1 minus x squared dx. So what I would do first is take out the constant 2/3, and then you're left with 1 over square root of 1 minus x squared dx. Now, what is the integration of 1 over square root of 1 minus x squared dx? And I would not use u substitution. This is a special one. This is one of your integration. This is one of your trig inverse. So 1 over, if you look at your rules of your inverse integration, 1 over square root of 1 minus x squared is sin inverse. And then our x is still x, right? And we still, remember we took out a 2/3, so it's 2/3 plus c. Okay, so that is your final answer. Okay, F. So what I would do is factor out the constant of 99 and 100. You're left with 1 over x square root of x squared minus 1 dx. 1 over x square root of x squared minus 1, that's a special one. Do not use u substitution. Is actually secant inverse of x. So if you look in your notes of your inverse integration, it is secant inverse. So this is going to be secant inverse of x, and then you're still left with 99 over 1. You're still left with the constant 99 100, so bring that down. Don't forget your plus c. Okay, next one. 3a. So we got to take the integration of x dx. So this time we're going to apply a power rule. So there's no constant you can take out. So we're going to apply the power rule. So this has a power of 1. So it's going to be power rule is just old power plus 1 divided by that power. So our old power is 1, then you add 1, which is 2, and then you put that 2 on the bottom. So this is equivalent to saying 1/2 x squared plus c. Okay, so I just apply power rule. B, the same thing, the integration of x squared dx. You just apply the powers. So the power is going to be old plus 1. So your old power is 2 plus 1, and then divide that by that power. So 2 plus 1 is 3 plus c. So you can rewrite this as 1/3 x to the 2 plus 1 is 3 plus c. Okay. C, integration of x cubed dx. So apply power rule. So it's old power plus 1, so that's 3 plus 1 over 4 plus c. So this can also be expressed as 1/4 x to the 4th plus c. Okay, d, integration of x to the 4th dx. So it's old plus 1, so 4 plus 1, and then it's 5 plus c. So this could be written as 1/5 x, and then 4 plus 1 is 5 plus c. Okay. E, same thing, power rule. So in the integration of x to the 62 dx, it's going to be old power plus 1 divided by that power. So 62 plus 1 is 63 plus c. So you can rewrite this as 1 over 63. So you can actually put the x in the center or on the top. It doesn't matter. So you can rewrite this as x to the 63, or you can rewrite this as x 63 over 63. They're the same thing. So you won't get marked wrong if you do that, but you will get marked wrong if you don't put the plus c. Okay, 4a. So integration of x to the -2 dx. So now we're dealing with negative powers, but it's okay. It's the same rule. It's the old power plus 1, so -2 plus 1 divided by that power. So -2 plus 1 is -1 plus c. So let's see if we can simplify this. This would be -1 x, and then what is -2 plus 1? -1 plus c. But could I make this as rewrite this as a positive power? Yes, we can. How do I rewrite x to the -1 as a positive power? It's just 1 over x, and then you still have this negative plus c. Okay, that's it. B, apply integration rules, the power rule. So it's old power plus 1 divided by that power. So -3 plus 1 is -3 plus 1 is -2. I'll put that in the bottom plus c. So it's going to be -3 plus 1 is -2 over -2 plus c. So this is going to be -1/2 x to the -2 plus c. Now, what if I want to write this as a positive? So x to the -2 as a positive power would be 1 over x squared times it by -1/2 plus c. So that is going to be, you can rewrite this as -1 over 2x squared and then plus c. Okay, c. Okay, so we have the integration of x to the 1/2. So now we're dealing with fraction power. Oh no, it's okay. So, but same idea. So it's the old power plus 1. So it's 1/2 plus 1 divided by that power. So what is 1/2 plus 1? Well, I can rewrite 1 as, because we're dealing with fractions, I can rewrite 1 as a fraction, or it could also be expressed as 2 over 2. So that would be 1/2 plus 2 over 2 is 3/2. So I'm going to divide that by 3/2. So this could be expressed as x to the 3/2 divided by 3 over 2 plus c. Okay, so we have, it looks strange, right? You have what's called a complex fraction. So if you want, you can rewrite this part right here. You can rewrite this as x to the 3/2, and then you have this long sign, which means divide. you write out the divide sign, and then your denominator is 3/2. Then what you could do is cross multiply. So 2 times x to the 3/2 is 2x to the 3/2, and then 1 times 3 is 3. And then don't forget the plus c. So that's how you can do it, that because you're dealing with complex fractions. Okay, letter D, same idea. Integration of x to the 1/3. So it's just old power plus 1, so 1/3 plus 1, or in our case, 1 could be expressed as 3/3, all over your power. So 1/3 plus 3/3 is 4/3. So let's simplify that. So it's x, and then 1/3 plus 3/3 is 4/3, divided by 4/3 plus c. So we can simplify it because we are dealing with the complex. So we can rewrite this as x to the 4/3, and then divided by 4/3. Cross multiply, so this would be 3x to the 4/3 over 4 plus c. A few more of these. So e, it's going to be x, and then your old power is -1/2, so add 1. So if we, I guess we can write 1 as 2/2, divided by that power. So what's -1/2 plus 2/2? It would be +1/2, right? So this could be expressed as x to the, what's -1? Oh, -1/2 plus 2/2 is +1/2 divided by 1/2. So that could be written as x to the 1/2 divided by 1/2. And then I would cross multiply. So 2 times x to the 1/2 is 2x to the 1/2. 1 times 1 is 1 plus c. So you can leave it like this. You can actually simplify it a little bit more. X to the 1/2 is the same thing as square root of x. Okay. Okay. F. So it's power rule again. So -2/3 plus 1, or in our case 3/3, divided by that power. So -2/3 plus 3/3 is 1/3. So -2/3 plus 3/3 is 3 minus 2 is 1/3. Cross multiply, so 3 times x to the 1/3 is 3x to the 1/3. And then 1 times 1 is 1 plus c. So 3x to the 1/3, you can leave it like that, or you can rewrite it as a 3 to the 1/3 is also the same thing as the cube root of x. And then don't forget the plus c. Okay, now let's do 5a, something different. Well, still power rule, but square root of the integration of square root of x dx. How do you take the integration of this? What I would do is rewrite it as a power. So square root of x is the same thing as x to the 1/2 dx, right? So how do I write it as a, now you can integrate this using power rule, right? So that would be 1/2 plus, so old power plus 1, so 1, or in our case, 1 could be expressed as 2/2. So that would be x to the 3/2 divided by that power. So we have a complex, so we can write this as x to the 3/2 divided by 3/2. Cross multiply, so that's 2 x to the 3/2 all over 3. And then don't forget the plus c. This is fine. You can leave it as a power. B. The integration of 1 over x squared dx, do not use natural log. I mean ln, because it'll only work if it was 1 over x. Instead, what I would do is rewrite it as a negative power. So 1 over x squared as a negative power is x to the -2 dx. So you can integrate this using power rules. So they would be -2 plus 1 over -2 plus 1 is -1. -2 plus 1 is -1 over -1 plus c. X to the -1 can be expressed as 1 over x, right? X to the -1 can be expressed as 1 over x. And then you still have this -1 plus c. Okay. C. What is the integration of the cube root of x squared dx? So I have no idea, but what I can do is rewrite it as a power. So how do I write the cube root? The cube root of x squared? That is equal to saying x to the 2/3. Okay. Okay, so how do I take the integration of that? Is you apply the power rule. So it's going to be x to the 2/3 plus 1. In our case, our 1 will be 3 over 3 divided by that power. So 2/3 plus 3 over 3 is 5/3. So this is going to be expressed as x to the, so 2/3 plus 3 over 3 is 5/3 divided by 5 over 3. So I can rewrite this as x to the 5/3 divided by 5 over 3. Cross multiply, so that's 3x to the 5/3. And then 1 times 5 is 5 plus c. Okay, that's your final answer. D is integration of 1 over square root of x dx. So that would be, I have no idea. I would not use substitution. Instead, I would rewrite it as a power. So this is a bit strange. 1 over, well, I know that square root of x as a power can be expressed as x to the 1/2 dx. But that's not really helping. So what I would do is rewrite it as a negative power. So this would be x to the -1/2 dx. So now we can take the integration that's using power rule. So it's going to be -1/2 plus 1, or in our case 2 over 2, divided by, so -1/2 plus 2 over 2 is +1/2. -1/2 plus 2 over 2 is 1/2 divided by 1/2. So that's going to be x to the 1/2 divided by 1 over 2. Cross multiply, so that's 2x to the 1/2 over 1. So 2x to the 1/2, I guess you can rewrite it as a square root of x. Let's see. Okay, 6a. How much do we have? Okay. 6a. So an integration of 2 over x cubed. So 2 is a constant, so I take that out. And then you have 1 over x cubed dx. Then I can rewrite this as 1 over x cubed as a negative power would be x to the -3 dx. So the integration of x to the -3 using power rule would be -3 plus 1 over that power. -3 plus 1 is -2. So that would be x to the -2 over -2. And then you're still left with that 2 from the outside. So that would be 2 divided by -2, that cancels. So you're left with -1 x to the -2. -1 x to the -2 would be, as a positive power, x to the -2 would be 1 over x squared. So that would be -1 over x squared plus c. B. So -1/4 is a constant, so take that out. Then what I would do is, I guess, what is integration square root of x? I guess I could rewrite it as a power. So what is the integration of x to the 1/2? Use power rule. So 1/2 plus 1, or 2 over 2, divided by that power. 1/2 plus 2 over 2 is 3/2. So that is x to the 1/2 plus 2 over 2 is 3/2, divided by 3 over 2, complex fraction. So that's x to the 3/2 divided by 3 over 2. Cross multiply, so that would be 2x to 3/2 over 3. And then I think we took out a -1/4, so multiply this by -1/4. So that would be -2x to 3/2 over 12. Let's see. So my final answer would be -x to the 3/2. And then 12 could be divided by 2, so that'd be 6. Okay, a few more. Let's do C. The integration of this. So first step I would do is take out the 5, or this 5 over 7. And then you still have the 4th root of x dx. So then what I would do is rewrite the 4th root of x as the power. So that's equivalent to saying x to the 1/4 dx. So now you just apply power rules. So it'd be 1/4 plus 1, in our case, would be 4 over 4, divided by that power. 1/4 plus 4 over 4 is 5/4. So that's x to the 1/4 plus 4 over 4 is 5/4, and then divided by 5 over 4. Cross multiply, so that's 4x to the 5/4 over 5. And then don't forget we took out 5/7, so multiply that out by 5/7. So that would be 20x to the 5/4 over 7 times 5 is 35. And then divide this by, I guess, 5. So 20 divided by 5 is 4x to the 5/4. 35 divided by 5 is 7. Let's see. Okay, that's it. D, integration -7 over 10x over 10x 9 dx. So first, take out that constant, which is -7/10. and then you're left with 1 over x9 dx. Then what I would do is rewrite 1 over x9 as a negative power, so x to the negative 9. And what's the integration of x to the negative 9? That would be negative 9 plus 1 over negative 9 plus 1 is negative 8. X to the negative 8 over negative 8. I guess that could be written as 1 over x to the 8th. And then you still have this negative 8. And then you got to multiply it by negative 7 over 10. So this would be negative 7. 10 times negative 8 is negative 80. Two negatives becomes a positive, so that's 7 over 80 x to the 8th plus c. And then can this 780 be reduced? I don't think so. No. So that would be your final answer. Okay, E. This is first take out the constant, which is 3/4. And then you're left with 1 over 5th root of x squared dx. And 1, I guess you can rewrite this as 1 over 5th root of x squared is 1 over. So how do I write the 5th root of x squared as a power? I think it's going to be x to the 2/5. Yes, 2/5, that's right. And then what I'm going to do is rewrite it as a negative power. So this is going to be expressed as x to the negative 2/5. And then apply the power rule. So negative 2/5 plus 1 or 5 over 5 divided by that power. So that would be 5 minus 2 is 3/5. So that is x to the 3/5 divided by 3/5. So that could be written as x to the 3/5 divided by 3 over 5. Cross multiply, so that would be 5x to the 3/5. 3, and then don't forget we took out that 3/4 plus c. So when you multiply, the 3's cancel, so you're left with 5x to the 3/5 over 4 plus c. Okay, 7. First I would do is get rid of this, move this constant, negative 27/5, so take it out. And then you're left with 1 over square root of x dx. Then what I would do is rewrite this as a negative power. So 1 over square root of x is x to the negative 1/2. Then what I would do is rewrite x to the negative 1/2 as a power. So that is plus 2 over 2. Negative 1/2 plus 2 over 2 is positive 1/2. That's x to the negative 1/2 plus 2 over 2 is positive 1/2 divided by 1 over 2. So that is going to be x to the 1/2 divided by 1 over 2. Cross multiply, so that's 2x to the 1/2 over 1. And then times this by negative 27/5. So that would be negative 54 x to the 1/2 over 5 plus c, and negative 54 over 5 be simplified? No. So your final answer would be, you can rewrite your final answer as negative 54 square root of x over 5 plus c. Okay, two more. So b, the integration of 6x to the 8th minus 12x to the 5 minus 2x dx. You could write out each problem separately because there are three terms, right? You can rewrite this as 6x 8 dx minus integration of 12x to the 5 dx minus integration of 2x dx. Or you could just take the integration of each term, it's fine. So let's just do integration of each term. So it looks like we're only going to use power rule. So what is the integration of 6x to the 8th? So it's 6x and then old power plus 1, so that's 8 plus 1 over 9. And then minus, what is the integration of negative 12x5? So that's minus 12x. And then 5 plus 1 is 6 divided by 6. And then this one right here is negative 2x. This has a power of 1, so 1 plus 1 is 2 over 2 plus c. Now it's clean up. 6/9 can be reduced by 3, so that would be 3x 9. Wait, 6 divided by 3 is not 3, it's 2. Because we're reducing by 3, right? 6 divided by 3 is 2. 9 divided by 3 is 3. Minus 12 over 6 is negative 2x to the 6. Negative 2 over 2 is just minus x squared. Let's see. Okay, so all I did was use the power rule, or if you want, you can take the integration each term separately, or using the sum rule, right? The same thing here. You could apply the sum rule, or you could just take the integration of each part of each term. There's 1, 2, 3. There's 4 terms. So let's start with the integration of 4x to the negative 1/2. So that'd be 4x and then negative 1/2 plus 1. Okay, so it would be 2 over 2. Negative 1/2 plus 2 over 2 is positive 1/2. I guess I'll clean that up later. Minus the integration of negative 5x to 3/2. That would be negative 5x and then 3 over 2 plus 1, or 2 over 2, over that new power. So 3/2 plus 2 over 2 is 5/2. Plus the integration of 6x is just 6x. This has a power 1, so 1 plus 1 is 2 divided by 2. And the integration of a constant, or negative 7, would be negative 7x. Okay, let's clean this up. So this would be 4x. Negative 1/2 plus 2 over 2 is 1/2, right? Negative 1/2 plus 2 over 2 is positive 1/2 over 1 over 2 minus 5x. 3/2 plus 2 over 2 is 5/2 over 5 over 2 plus 6x. 1 plus 1 is 2 over 2 minus 6x and then the plus c. Okay, now we have is a complex fraction, so maybe we can write this as 4x to the 1/2 divided by 1 over 2. Cross multiply, so 4 times that would be 8x to the 1/2, right? Over 1. And then minus, this is also a complex fraction, so you can write this as 5x to the 5/2 divided by 5/2. Cross multiply, so this would be 10x to the 5/2, and then 1 times 5 is 5. 10 divided by 5 is 2x to the 5/2. And then 6x squared over 2 is just 3x squared minus 7x plus c. And then can we simplify anymore? I guess if you want, so this is your final answer. 8x to the 1/2, well, that's really x. 8 square root of x. You know what, let's just put everything in power, because everything else is in power, so this would be 8x to the 1/2. Okay, so that is your final answer. Okay, so this is part one of practice problem integration rules. I'm going to stop here.